Welcome to ClickMyProject.com. This is my project title FastGEMF Scalable High-Speed Simulation of Stochastic Spreading Process over Complex Multi-Layer Networks. This is our project abstract. Predicting how things spread like disease information or computer virus across large layered network is a big challenge. These systems are complex and dynamic, can be hard to track. FastGEMF is a new high-speed simulation tool that solves this. It models how things spread across multi-layered networks with millions of nodes and edges quickly and accurately. Inspired by Gillespie algorithm, it uses an event-driven approach with logarithmic time complexity per event, making it one of most efficient tools available. FastGEMF support many types of spreading model and is especially used for medical dataset, helping researchers simulate and understand how disease progress in population. It's perfect for application in epidemiology, cybersecurity, and information propagation. FastGEMF is written in Python, open source, and designed to accelerate advanced research. It provides an exact scalable framework for model validation and comparative analysis across complex network-based spreading process. This is a flow diagram. The process starts by data load and model. If data load successful, proceed X, initialize web server and node. If data is unsuccessful, log error and exit. Then wait for a user request. User can pick from 3 tools: simulation module, network explorer module, system checker module. Simulation module run disease spread simulation and calculate statistical output, and network exploration fetch node or edges from disease network for visualization, and then system checker use ML model to predict disease based on input symptoms. Each module process request and return result to web server. System render interactive network graph for data visualization. Final output includes simulation report and network insights and diagnostic prediction. This is a project explanation part. First, load data and model. This is the critical step. It directly powers the output, and then after that user request in simulation module. This process in our application: simple simulation and advanced simulation is using an event-driven Gillespie algorithm modeling transaction like infection or recovery time. It updates event efficiently with logarithmic per step, enabling fast and large scale. And then next step, network explorer module. In this step in our application, it's an interactive tool and it helps visualize and interact with the structure of network used in simulation. And then next, predict disease and from symptoms checker module. This process in our application is the tool that take user reported system as input and predict disease. Use a trained ML model to analyze symptoms and provide likely diagnosis. And this is our project source code. This is our project output. This is the dashboard, and click simple simulation and select any one disease. Click the run simulation. Is used to analysis spread using present parameter for infection and recovery rate. This report shows the 85 days of progression of allergy through key metrics like disease spread and infection rate. User can analysis peak, infection period, and recovery rate. And then click final outcome. This is the pie chart. It tracks the infection rate and key metrics while comparing affected value and unaffected population. This data visualization highlights pattern with other diseases like chickenpox, AIDS, And then next, click infection rate. This simulation track allergies progression over 85 days, measuring disease spread and infection rate at 5-day interval. Key metrics reveals transmission pattern from day 0 through day 85, showing new infection trend throughout the outbreaks. And next, simulation key metrics. Results show 41 total affected case with peak of 17 active infection. A network risk score of 6 indicates moderate transmission potential across the population. And go back to dashboard, click the advanced simulation. This is advanced simulation module allows users to conduct what if scenarios analysis for various disease. User first select a target disease from drop down menu, then fine tune parameter using interactive slide for infection rate and recovery rate. Click the run simulation and view to disease spread, final outcome, then infection rate and also key metrics. Then next, click connection explorer, select any one disease, the network graph map chickenpox disease using a red line strong connection and then blue line is a weak connection. This chickenpox, the strong connection is a tuberculosis, common cold and then dengue. All are the weak connections. And then next, click on disease recommendation, click any symptoms, then click will get recommendation. Recommended disease is a fungal infection. And then click the model performance report. The system achieved 97.62% overall accuracy in diagnosing condition from symptoms during testing. And then next, 3D network explorer is an interactive tool visualize disease relationship in 3D space, where each node represent a medical condition. User can rotate the graph by dragging and zooming with scroll gesture. And this red node is a strong connection and blue is a weak connection. This visualization help identifying symptoms, disease linkage for diagnostic support. Thank you.